So we talked yesterday about what matter is, and we said that matter is essentially the stuff that makes up everything. And we talked about the difference between mass and weight, and we said that mass is how much stuff is in an object, whereas weight is a measure of the force of gravity that's acting on that object, right? And we talked about how mass was constant because the amount of stuff making something up is always the same, whereas weight can change, right? Because weight can change with location, right? If you go someplace that has a different amount of gravity acting on it, your weight can actually alter and change. So we're going to do a worksheet today looking at the difference between mass and weight. So the first thing that it asks us to do is to put our name, date, and period. So I'm going to put my name. You guys will fill in the date that you're working on this and then your period number, okay? And then it asks us to define mass, define weight, and talk about which one changes based on where you go. So let's do mass first. We talked about mass a bunch in our last lesson, and we said that mass is a measure of how much matter or stuff is in an object. Okay, so the more stuff making up that object, right, the more mass, right, the heavier it's going to seem. A desk has a larger mass than a pen. A pen has a larger mass than a paperclip, just because there's more matter that's going into making it up. Weight is a totally different concept, right? We talked about how we use the term mass and weight a lot as if they're interchangeable, but they're really completely different concepts. So weight is actually a measure of the force of gravity acting on an object. This is actually figuring out how much gravity is pulling on that object. And it's actually a calculation, right? Weight equals mass times gravity, right? You have the mass, right? How much stuff makes it up. You multiply it by this gravitational field or the surface gravity, and you'll get the weight. And then it asks us which one of these changes based on where we go. Okay, so we know that mass is always going to be the same. It's constant, right? The amount of atoms that are coming together to make up your notebook are the same whether you have that notebook in the kitchen, at the equator, at the North Pole, on the moon, right? The amount of stuff making up that notebook is the same. Whereas weight actually can change, right? Your weight of your notebook on Earth versus the weight of the notebook on the moon is different, okay? Weight changes based on where you go, since gravity can change based on where you go. So now it asks us to calculate your friends or siblings or pets' weight and mass on the different planets or moons. Okay, so again, you're going to pick some type of living thing, whether it's you, a parent, a friend, a sibling, a pet, whoever it is. It has to be someone whose weight that you know. So if you know that you have a dog that weighs 17 pounds, you could do it. If you know that your little sister weighs 60 pounds, you could do it. You're going to pick a weight that you know, okay? And you're going to figure out what its mass on Earth is versus converting it into kilograms. Now, like we said, right, we kind of use those terms mass and weight interchangeably on Earth, even though they mean different things. And the reason that we use them a lot interchangeably on Earth is because Earth has a surface gravity of 1 gram, essentially. So because we set, right, the ratio here, so your mass on Earth and your weight on Earth are actually the same number, though we use a different unit. And that's why we kind of got into this habit of using them interchangeably. So if you know what you think is your dog's weight, that's actually your dog's mass, okay? Usually in pounds. So let's say that I have a 36-pound dog, okay? It's asking me to take this amount in pounds and to convert it to kilograms, okay? So that's the first step. So in a new tab in Google, you're gonna type in pounds to kilograms, and a conversion calculator will come up for you. So if you know that your dog is 36 pounds, you can come here and where it says pounds, you can type in 36, and it will tell you how many kilograms that is. If it's a long decimal, we're just going to round to the tenths place. So 0.3 is in the tenths place. I look to the place behind it to see if I have to round up or down. It's a 2, which is less than 5, so that rounds down. The 3 stays the same and everything else cancels. So this would become 16.3. Okay, so I come back to my worksheet. 16.3 kilograms. 36 pounds equals 16.3 kilograms. So that is the mass of your dog in kilograms. So the first thing that it asks us is, on Earth, what is the mass in kilograms of this living being? So it would be 16.3, okay? Now, we said that to find weight, which is what we're looking for in the last column, you take mass, you multiply it by the gravity, and you'll get the weight. So in this middle column, they've told us what the surface gravity is for all of these different planets and moons. So you have to take this first number, you multiply it by the second number, and you get your answer for weight. Now, mass we're measuring in kilograms. Surface gravity we're measuring in grams, and this is going to give us newtons as our final unit. So again, we can come back here, we can type in calculator. The first one obviously is going to be very easy. You should be able to do it in your head. 16.3 multiplied by 1 is going to get us 16.3, right? You multiply any number by 1 and you get the original number. So 16.3, but the unit here changes to be in newtons, whereas our original mass was in kilograms. Okay. Then we have the moon, right? Our original mass, okay, because mass stays the same, would be 16.3 kilograms. This number is going to stay constant our whole column. What we'll see, though, is that the surface gravity, right, the force of the gravitational field actually is different for the moon, right? There's a different pull of gravity happening on Earth versus the moon. So now we have to take our 16.3 mass, multiply it by our new gravitational factor, and then we'll get our weight. So 16.3 multiplied by this number, 0.1654. We come back to our calculator. 16.3 multiplied by 0.1654 equals 2.69. And again, we're going to round to the tenths place. So we look at this number, we look at the number after, it's higher than 5, this rounds up, so 2.7 newtons. That's a big difference, right? If we look at our weight on Earth versus our weight on the moon, significant difference, right? So what you're gonna do is you're gonna keep filling in this chart, okay? And you're gonna figure out how that weight is going to change for all of these different planets and moons. Now remember, this mass column here is going to stay consistent, right? It's always going to be 16.3 because the amount of stuff making up your dog is not going to change, okay? So this whole column will stay the same. And then what happens is you have to take that mass, multiply it by the gravitational force for each of these different planets and moons to figure out how your weight will change. Okay, Make sure you fill in the entire worksheet. Make sure that all of your columns, right, that you're typing into have a unit next to the number. Mass should have kilograms. The weight should have newtons. Okay. And don't forget to fill in your definitions that we went over and put the original mass conversion at the top. Okay. Once your document is done and it's completely filled in, you can submit this on Classroom. If you have any questions, let me know.